Hello and welcome back to Technology Now, a weekly show from Hewlett Packard Enterprise where we take what's happening in the world and explore how it's changing the way organizations are using technology. We're your hosts, Michael Bird
and Aubrey Lovell. And in this episode, we are looking at a sector where IT and tech innovation is taking efficiency to a whole new level: manufacturing. We'll be exploring how digital twins, AI, and IoT are revolutionizing production lines. We'll be looking at whether more efficient manufacturing is a route to decarbonization and more efficient supply chains, and we'll be asking what the rest of our organizations can learn from it.
Yes, indeed. And if you're the kind of person who needs to know why what's going on in the world matters to your organization, then this podcast, of course, is for you. And if you haven't yet done so, do make sure you subscribe on your podcast app of choice so you don't miss out. Right, Aubrey, let's do it. Manufacturing is a massive part of the global economy. According to the UN's Industrial Development Organization, around 816 million people globally work in the industry, with around 143 million directly employed in manufacturing, according to figures from Statista. And we've linked to both of those in the show notes.
That said, manufacturing is in a precarious position as an industry. In the global north, growth is largely stagnant, according to those same UN statistics. Even in high-growth economies like China, it's slowing down. Manufacturing is also not an especially efficient industry. Statista gives us a global average figure of 44% for so-called manufacturing intensity, which is a measure of how much energy is needed to produce something. So clearly, there's a lot of room and a lot of very good reasons to make manufacturing more efficient, especially in the automotive industry, which was the least efficient of all sectors. After all, to grow, you can either earn more from selling a product or spend less making it.
Right, but how and what lessons can the rest of us take from a potential technological revolution in manufacturing? Well, joining us to explore the issue is Dan Klein. Dan is an advisor on data and digital transformation, having worked with everyone from record labels to government departments with a special interest in the manufacturing sector. So Dan, let's start off with the obvious question. What are the major inefficiencies in manufacturing and how can recent developments in tech help?
If we look at manufacturing more broadly, there is always a struggle. I have a very live example at the moment of a factory in Livingston that I visited recently. Livingston, Central Belt in Scotland. The factory has a scheduling system for its members of staff and its bits of equipment. And it's quite a big factory. It's 1 million square meters of factory space. And this is in 2025 we're talking about. They have one aging PC sitting in the middle of the factory floor that is not connected to the internet. And it is running the whole factory. So we're starting from a very, very low base. So I think a lot of the challenges with manufacturing is just to bring themselves into 2025. Aside from doing anything clever, there's some basic process improvements, some basic improvements in, if we look at decarbonisation in the manufacturing space, for instance, the number one thing on the list for decarbonisation in manufacturing is the replacement of boilers randomly. Because a lot of these boilers are probably boilers that were fitted 30, 50, 60 years ago, haven't been changed. Well, if you change them, you can change the carbon footprint of our manufacturing base. But we need to invest in manufacturing in the basics. And actually tech is, everybody gets very excited about it. But unless you've got the basics right, that tech isn't really going to help you. In fact, if anything, it's just going to be money wasted. So I'm a great believer in making sure we spend the money where it's actually needed. And the tech will come, but you have to get the basics right. You have to get the data moving around. You have to get in this case, this particular factory at Livingston, you have to get them connected up. You have to get them into an environment where you can actually do something with it. Otherwise, you really are on a hiding to nothing. Again, I talk to manufacturing environments a lot where they talk about IoT devices, for example, and a lot of them have got IoT devices. They're connected up to old programmable logic controllers from back in the day, right? And so a lot of the question is, okay, so what's the investment line side to enable you to then start using a lot of this IoT and this clever tech and this clever data? But unless you've got that line side investment to start with, and there's got to be a really good business case for it, what's the process improvement you're going to get out of it, right?
In your experience, and I'm going to use this word because it would be remiss of me to not use it. In your experience, are you seeing, particularly from a data perspective, are you seeing machine learning and AI starting to make an impact? I mean, particularly when you're talking about those sorts of factories have a single computer running things. Like, are you starting to see that actually in other factories and other manufacturing environments, like AI is starting to make a difference and is starting to be a tool that is like a vital part of the process?
I'm going to say yes and no. Look, there are some places where, if I look at what I was doing in the early 90s, which was around computer vision, fundamentally it's machine learning, and these days it's a decent amount of deep learning as well. Computer vision in a factory setting has changed beyond all recognition and is amazing. So the answer is yes, there's absolutely machine learning and deep learning within computer vision inside a factory setting.
And so that's where you have like a production line of potatoes or something, and it will look for defects rather than a human having to look for defects. It will scan everything going past it and it will say, oh, that one,
Yeah, and in fact, so you're absolutely right. I had a team in Germany last year doing exactly that with a food processing company, right? So this stuff exists. And absolutely, you're absolutely right. Food processing company, cameras all over the place, looking at vegetables more broadly, actually, it wasn't just potatoes. Where I struggle is where you start talking about the use of machine learning and deep learning and other techniques away from sort of some of the more, something like computer vision is it's a very straightforward use case in some senses, because I can point a camera at something and I can do something interesting with that camera, and it tends to be looking at a flow of a production line, and that's great. But say the wider use of data analytics techniques across the entire process flow in a manufacturing environment, I haven't seen good examples of that. And that's where you get a lot of the challenge, if you like, is the wider use of it away from some very specific things. If I just go slightly sideways across, again, another German project from a couple of years ago now, but we were using machine learning. Again, it was computer vision, but it was measuring the impact of hailstorms on cars and paying out insurance claims. But again, it's computer vision. So the computer vision has definitely got a place in manufacturing. I'm more interested in some of the techniques being used elsewhere, aside from just the straight computer vision environment.
Can we talk digital twins? Because I'm hearing this term increasingly, in particular when it relates to the world of manufacturing. Can you just sort of explain what digital twins are, how it works, why it's an important part of a process?
Fundamentally, the digital twin is a simulation on steroids. I'm being slightly facetious, but what you want from a real digital twin is you have live data coming off the production environment, providing you with a live view of the production environment, which allows you to simulate and scenario plan what happens if we did this. Why do people get excited about digital twins? They get excited because you can test ideas out without actually changing the actual infrastructure itself. Now, why is that important? We have a lot of infrastructure that's been around a long time. We land up with legacy environments that have been around 150 years. So you're now saying, let's take London Underground. Great. I mean, I've worked on London Underground. It's a great example. How on earth do you upgrade something where you are continuing to move passengers every day without shutting any lines down? So what you want, and this is why digital twins become so important, you want to be able to scenario plan and test and work out what's going to work, what's not going to work. But you want to do it on the live system without being on the live system. And fundamentally, that's what digital twin gives you. Is it machine learning? Is it deep learning? Is it any of the really clever stuff? No. Fundamentally, it's live stream data doing a replicated environment. Now, I started life in the aircraft industry. The aircraft industry, for better or for worse, probably has the closest anyone's getting to a digital twin. So they've had very, very good simulations of pretty much everything on an aircraft for years. Now, do they build those off live stream of data sets? Increasingly, they do, actually. The challenge for everybody else is they probably haven't spent the money in simulation that, say, the aircraft industry has over the last 40, 50 years.
I would imagine that to make that digital twin as accurate as possible, you need to have a good amount of data. So I suppose lots of sensors. Aircrafts have lots of sensors. So that's, seemingly provides ample amounts of data. I imagine a race car would have lots of sensors, so loads of data. But from a manufacturing perspective, I wonder, and if you're talking about legacy systems, I wonder if some of those would have lots of sensors. So how do you get around that problem? Or is it a problem?
I don't think you get around it. And it isn't a problem. It's just that you will have to annotate your system with a lot of sensors. It goes with the territory. If what you want to do is a digital twin, you will have to annotate your system with sensors. One of the topics that's really big in the UK at the moment, and it's associated with decarbonisation, is building a digital twin of the energy network in the UK. So this is everything from, and we see it with the loss of a substation next to Heathrow. The question is, do we understand what happens when things go wrong? Do we understand what happens if we change things? Did anybody completely understand the impact of a substation at Heathrow going out? So the question is, can we have a digital twin that gives us a live feed of what's going on in the network, real time, that allows us to scenario plan, not just for things going wrong, but also for what happens if we upgrade. So if we wanted to upgrade a large part of the UK, let's talk about digital twins for Europe. What happens if we wanted to upgrade one of the big interconnects between France and the UK? What's the impact? Can we look at what that does? If we put a wind farm in the middle of the North Sea and we send some of the electricity to Denmark and some of the electricity to the UK, what's the impact? The digital twin for the infrastructure is super important because it allows us to work out what we can do. And at the moment, when we roll out a major change, we sort of are flying by the seat of our pants. We're not, in the sense that we've probably done a lot of due diligence and scenario plan to work out, is this actually going to work? But as an engineer, I would rather have a full-blown live simulation to check. It makes me feel comfortable that I've tested the hell out of this before I put it anywhere near anything.
So just, I guess, going back to manufacturing then, what do you see as the next big innovations that are going to be impacting the world of manufacturing over the next year, 5 years, 10 years? Particularly because you're saying, many of these manufacturing facilities, the equipment's quite old, running on a single computer. I mean, do you think that's just going to be the case for the next decade? Or do you think actually the innovation of tech is they're going to have to implement that in order to be able to keep up with, what their competitors are doing?
Manufacturing is going to have to innovate in order to keep up. The trick is, what do you innovate? What you don't want to do is throw innovation at manufacturing just for the sake of it. What you want to be doing is focusing very clearly on the bits that need upgrading. So if you're looking at processing plants, what bits of the processing needs upgrading and why? And then do you find the relevant tech for it? I do think there's increasingly a much bigger role for vision to play in a manufacturing environment. I think vision will start to move away from just looking at things moving along a conveyor belt, which is where vision is at the moment, really, in the manufacturing environment. I think digital twins will become a thing, but I think they will become something that where you're looking at a digital twin of a very big environment. Cause and effect is a really big area, I think, where manufacturing environments are loath to upgrade things because they're worried that if they upgrade it, they break it. And if they break it, they stop making money. The big one for me with manufacturing is to start putting sensors in everywhere and start looking at the sensors you've already got and saying, are they fit for purpose? And do they give us the information we actually need?
Thanks, Dan. That was fabulous. There's some amazing insights in there. All right, now it's time for Today I Learned, the part of the show where we take a look at something happening in the world we think you should know about. All right, Michael, what do we have?
Well, Aubrey, now it's fairly well accepted by most experts that there is a lot of water in the solar system. In particular, the ice moons of Jupiter are believed to have vast oceans underneath their icy surfaces. But until now, Mars has not been a candidate for a water world. It's thought Mars did once have planet-spanning oceans, but they dried out hundreds of millions of years ago. But that could be about to change, though, because scientists in Japan, writing in the journal Geoscience World, believe they may have found evidence for a subsurface ocean deep within the red planet. Using seismic data from Marsquakes, that is, earthquakes on Mars, gathered by NASA's InSight lander between 2018 and 2022, a group of researchers from across Japan have found evidence that Mars contains vast pockets of liquid water between 7 and 12 miles, that's 11.5 to 20 kilometers underground.
Interesting.
Now, in the past, geologists have dismissed these pockets as simply changes in rock structure. But by running tests on similar rocks found in Sweden, the team claims to have proven that seismic data is showing liquid water. And a lot. Enough, theoretically, to coat the planet in an ocean with half the average depth of Earth's, which is pretty interesting. But, Aubrey, don't get too excited. There's no way with current tech, we could ever get close to that water. The deepest hole ever drilled on Earth, the Kola super deep borehole in Russia, was just over 7 miles or 12 kilometers deep and took decades to drill. Doing that on Mars isn't going to happen anytime soon.
Thanks for that, Michael. Very interesting. I'm still stuck on the Mars quakes. I think I'm happy to stay on Earth, actually. So that's great.
Right. Now it is time to return to our guest, Dan Klein, to talk about technology in the world of manufacturing. What sorts of industries are going to see the biggest benefits from having more sensors and more information to improve efficiency?
Fluid processing more broadly, so oil, gas, any of the more traditional hydrocarbon industries. But then some of the projects I've had teams working on over the years, the engineering industry in terms of manufacturing of cars, planes, ships, they're all going to be, so anybody in the supply chain for the car industry, I think is going to need to upgrade their manufacturing environment for their parts, for instance. But I think the traditional industrials, I think there's going to be a huge input when it comes to IoT devices and then what they can do with it in terms of data and digital twins.
So outside of simply reducing costs and improving efficiency, are there any tangential benefits of tech-optimized production lines?
I suppose I wouldn't call it a tangential benefit, but you may want to call it a tangential benefit. The primary benefit actually is you have a workforce that is tech-savvy, which I actually think is the primary benefit, because if they are tech-savvy and they are highly trained and highly experienced, they will continue to develop the factory environments to be competitive. We have to be, for me, with the manufacturing sector, we have to be mindful that the staff don't become de-skilled in running a factory environment. I'm always really saddened when I see manufacturing engineers inside a factory environment who've probably been a manufacturing engineer for 30 years and they've effectively de-skilled. And so for me, it's about keeping the skill base of our workforce up to date by giving them access to the new tech and giving them access to try out these new process ideas so that they don't feel left behind. And actually, I wouldn't call that tangential. I'd call that it's absolutely crucial to the manufacturing base. Otherwise, we're in trouble because we'll get left behind, particularly with people like China. And of course, China has an advantage. They don't have lots of legacy manufacturing and legacy infrastructure. They're building it from scratch for new in the last 10 years, right? So it is going to be better because they haven't had to work around an old factory layout. Now, I'm always minded by the infamous Longbridge car factory. The fundamental reason why that factory shut was that they never moved the paint shop after World War II. They had 70 years to move a paint shop. They never moved it. What that meant was the paint shop was the wrong side of the road, so they used to ship the cars over the top and underneath in a tunnel. And it was like, guys, you should have moved that paint shop years ago. And this is the thing, that we got left behind. That car factory got left behind. It's really sad. And so for me, it's about the staff not being left behind and actually continuing to invest and continue to invest in staff and continue to invest in the infrastructure within the factory environment that makes it a relevant factory for the future.
So final question then, for those outside of the manufacturing space, why should those organizations care about the improvements, particularly the improvements that we talked about in the world of manufacturing and industry?
We should all care about manufacturing because at the end of the day, it's one of the big economic providers, it's value adders in the country. It's about jobs. Let's get political about it. It's about jobs. It's about our own ability to make things. And each country in the world has to find its niche on what it's good at making. We have to create an environment where people are able to create things and make things for the local population so that we don't have to ship stuff halfway around the world and have a carbon footprint that matches it, right? We have to be able to make stuff locally. And also we have to be able to service things locally. We need the skill base in the manufacturing to do that.
Thanks so much, Dan. It's been great to hear from you. And you can find more on the topics discussed in today's episode in the show notes. All right, well, we're getting towards the end of the show, which means it's time for This Week in History, a look at monumental events in the world of business and technology, which has changed our lives. Michael, you are up.
Okay, well, the clue last week was it's 1903, and this discovery was certainly a hot one. Aubrey, I think you got this last week. I think you said something to do with radiation.
I don't even remember.
Maybe you said that off air. But anyway, either way, it was the discovery of radiation in radium by Pierre and Marie Curie.
Nice.
It was reported at the time that the pair wrote to the Academy of Sciences in Stockholm that their newly discovered element could emit heat for months at a time with no obvious chemical change, enough to melt more than its own weight in ice every hour. They also discovered that by holding a tube of radium close to your skin for several hours, it produced an open sore. Please Please don't try that at home. Because of the pair's findings around radium and radiation, they were awarded the 1903 Nobel Prize in Physics. The award cemented their position as some of the most famous scientists of the 20th century. Pretty awesome. Aubrey, what's the clue for next week?
Well, it's 1932, and you know what they say, when life gives you lemons, isolate compounds.
They do say
Any
that.
ideas, Michael?
They do say that. Acidics, lemons, something to do with something acid. I think, you can make batteries out of lemons. Maybe something to do with that. I don't know.
It's a good guess. We will find out next week. And that brings us to the end of Technology Now for this week. Thank you to our guest, Dan Klein, and to our listeners, thank you so much for joining us.
Technology Now is hosted by Aubrey Lovell and myself, Michael Bird. And this episode was produced by Sam Dattapoulin and Lincoln Funder Vesthazen, with production support from Harry Morton, Zoe Anderson, Alicia Kempson-Taylor, Alison Paisley, and Alyssa Mitchery.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, Katie Guarino, and our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Lower Street production for Hewlett Packard Enterprise, and we'll see you at the same time, the same place next week. Cheers.